Alrighty, I'm gonna see how quickly and simply I can explain this worksheet to y'all so y'all get it without wasting too much of your time. So you have your example coordinates, whoops, and you have to list the domain and the range of those examples. So you have -3, -1, 0, 4, 4, 5. So if you have duplicates, list them both. Same thing with your range. You have to put them in numerical order. That's just the standard of doing it. And your nines repeat, so you have to list them twice. These are just naming things. This is the set of ordered pairs. This is a table. This is a graph. This is a mapping diagram. And this is the equation of a line. Not much to explain there, so we move on. So here you have to figure out which mapping diagram corresponds to this. So you want to look at these 2 points right here. That's 3. Your x's repeat on 3. So you can see here, 3 only goes out 1. Same thing there. And then 3 here, it does go out, but your 2, there's only one of your 2. And it goes out twice here, so it can't be that one. That leaves you with D. Then you do the opposite here. You're just gonna go 2, 5, 5, 9, 9, 3. Makes life easy. You just gotta count. Now the page breaks here. So you're trying to find out whether it's a function or a relation. If the x's repeat, it's just a relation, not a function. So here you have 2, 4, 6, and 8. That makes it a function because your x's do not repeat. This one is a function because it's not stemming off. Your domain doesn't go off to 2 places. So it is a function. And then the third one is a relation because if you use the vertical line test, you can see that both of these are repeating. Then on 4, none of your domain repeats, none of your x's repeat, so it is a function. This is also a function. They're all good here. And then this one is no good because this -3 goes off to the 6 and to the 0, making it just a relation. So now on this one, on exercise 4, on the first problem, it just wants to know which x value can make this stay a function. And since 5, 7, and 9 are 3 of your options, can't use those and keep it a function, so you have to go with 4. Now for these 2, you just have to figure out if they are a function or not. Your 5s repeat here, your 3s repeat here. Neither of them are functions. So now you have to identify these as relations or functions. It's pretty simple. It's just vertical line test. This one fails, this one passes, this one looks like it could fail, but it doesn't. It's not quite sure what type of graph that is, but it passes. 2 more here. This one passes, the x's don't repeat, and same thing on here. So this one was our only relation. All right. So this is just graphing. These are your x's, these are your y's. Graph your x's to your y's. -1, -2, 1, -1, 1, 0, 2, 2, 3, 2. You can see that your 1 stems off to 2 places, so it's not a function. And if you vertical line test on the second problem, it is not a function. And then you just do this thing in reverse. List them in least to greatest order, and then draw your arrows. Same thing on this one. Not a function. 1's repeat. And then on this one, you're just writing them as a set of ordered pairs. So you're just finding your points. I prefer to take the smallest x and go in order from there. So from left to right. And it is a function because none of the x's repeat. Now here's some of the weird stuff. If you have an empty dot you're going to use a parenthesis to symbolize less than or greater than. And if you have a closed dot, then you're going to use that to symbolize less than or equal to or greater than or equal to. Though the easiest way I think to remember this is that the brackets, they kind of have their flat edges, like the greater than or equal to. I think that's the easiest way to remember it. So you can see here that this is open. Start with the domain. Your x's go left to right. So this one's the furthest left. It's open, so it's -2, parenthesis. And then this one's furthest right. It's closed, so you use a bracket, which is 2. And then repeat with the range. So this is open. It's at the bottom of your range because it goes from bottom top. So -2, 1. Looks like I need a comma there. And after the 1, you put a bracket because this is closed. And it is a function because none of your x's repeat. Whenever you have just lines that touch, that is as if you had a filled-in circle like here, which means you have to treat them as such and you use brackets. So it goes out to -3 on this side and 1 on this side, brackets on both sides. Oops. Same thing here, it goes down to -1, 2, 3, brackets on both sides. It's not a function. It fails the vertical line check. Then this one, your domain is simple. You have 2 open dots. You go from left to right, so -2, 2 in parentheses. But the range, you can't just look at both of these, be like, okay, they're both at 2, so my range is 2, because that doesn't work. You have to take the very bottom of your range, so as if this were the edge of the circle, like in this problem. So these are inclusive, like on the circle. So this goes down to -4, so it is bracket -4, and this goes up to 0, so it is 0 bracket, and it is a function. Then you have these 4. These are pretty easy. You just take your x's and your y's, you put them in numerical order, and you close them in braces. Then you take your f of whatever, in this case 10. You find the x that's associated with it, not the y. Be careful of that. And then you find its associated y, and you make it equal that, and I put the point there just to be safe. It's kind of the same thing on all of these, just formatted a little bit differently. Now in this one, it's kind of the same thing as before. Check your left. It's a filled-in dot. It's a bracket, so it goes from 0, open dot, so it goes to 8, which is a brace. Now your range, the bottom of your range is -3 inclusive, because this one, they're both at the same level, but this one is a closed dot, and that takes precedence over the open. And then this is a line touching it, so it is also a brace because it is touching it. It's a less than or equal to. And kind of same thing with the f of 0. It's 3. You just kind of got to look and count. And this one shoots off to infinity. So if you look at your domain, your x's, it starts at 0 with a closed dot, and then there's no end to it. It will just keep going up. So it goes off to positive infinity, and since you cannot hit infinity, you can always go higher. You're going to close it off with a parenthesis. That's with both negative and positive infinity. Now, kind of the same thing here, except it's just a line that touches it. So it's a bracket -3 for inclusive. That shoots off to infinity, so it's to positive infinity, parenthesis. Now, on this one, there are no dots. In fact, it basically goes off infinitely in all directions except up. So for your domain, it goes infinitely to the left, infinitely to the right. So negative infinity, positive infinity, parentheses. As for your range, it goes infinitely down, but it does stop at 4. So, and that is a line, so it is inclusive, so you use a bracket. Then on this W thing, your domain is infinite because these will go off infinitely into the left and to the right. So your domain is negative infinity to positive infinity. Parentheses. And then it stops at negative 6. It's a line touching it, so it is inclusive. And it shoots up to infinity, so bracket negative 6 to positive infinity, parenthesis. Then this one, if you look at the domain, this part's going down all the way to infinity. This part's, to the left to infinity, and this one's going to the right to infinity. So your domain is negative infinity to positive infinity in parentheses. And your range, it goes down infinitely, and this goes up infinitely. So your range is negative infinity to positive infinity. I hope that was simple and understandable. If not, let me know.